we are beginning with Unit 6 of our subject Introduction to Deep Learning. This unit is about RNN, LSTM and GRU. So, let us begin with it. Our first topic in this unit is RNN. R stands for recurrent, NN as usual that we are studying neural network. So, RNN stands for recurrent neural network. In recurrent neural network, this is basically a type of artificial neural network which uses sequential data or time series data. Basically, this RNN, it works on the principle of saving the output of a particular layer and then feeding this back to the input to predict the output of the layer. So, in this, we are providing the feedback paths. That means, in recurrent neural network, the output of one layer can be fed back to the input of another layer. So, that means there are feedback paths in our recurrent neural network. So, basically, what is RNN? RNN is a type of artificial neural network which uses a sequential data or the time series data. They are distinguished by their memory as they take the information from the prior inputs to influence the current input and the output. So, the basic things which distinguish this RNN from the feed-forward neural network is our memory. They have a memory which stores the output of one layer, and if required, this output can be fed back to the input of previous layer to obtain the correct result. Like feed-forward and the convolutional neural network that we have studied in the previous units. Recurrent neural network, it utilizes the training set, the training data to learn. In this RNN, we are utilizing some training data which are used for the purpose of learning. So, basically, it works on the principle of saving the output and feeding this back to the input. So, it can be distinguished from the previous feed-forward neural network and convolutional neural network because it has a memory which stores the output of one layer, and since it is stored in this memory, it can be fed back to the input again. These deep learning algorithms, they are commonly used for ordinal or temporal problems. Like what? Like for language translation they can be used, for natural language processing they can be used, for the purpose of speech recognition, image captioning. So, in all these applications, we can use these types of algorithm. They are incorporated into many popular applications that we are using nowadays, like we have Siri, we have Alexa, we have the Google Translator, the voice searches. Everywhere we are using these types of algorithms. So, till now we have understood the difference between RNN and the neural network that we have talked about earlier, which was like feed-forward or maybe CNN. So, in this RNN, we have a feedback path from where the output of one unit can go back to the input of the previous unit. A feed-forward neural network, it allows the information to flow only in one direction, from the input nodes through the hidden layer and to the output nodes. We have understood that in the neural network, we have the input layer, then we have certain hidden nodes, and then we have the output layer. So, in our feed-forward network, there are no cycles, no loops, no feedback paths. So, that is why RNN was created, to overcome the issues that we were facing in our feed-forward neural network. What were the issues that our feed-forward neural networks were facing? They could not handle the sequential data. They were considering only the current input and they could not memorize the previous input. So to overcome these particular issues, that sometimes we want to handle the sequential data, means the data which is coming in sequence, we want to take it back to achieve the right results. Sometimes we want our output to consider the outputs occurred in the previous stages. So we need some memory to store these previous inputs. So to handle these kinds of issues, our recurrent neural networks was discovered. As we can see from the figure given here, that what is feed-forward neural network and what is RNN. In feed-forward neural network, we have simply the input layer, we have various hidden layers, and following it is our output layer. Now, how can this be converted into the recurrent neural network? We have input layer, we have the hidden layers. In these hidden layers, we have a memory which stores the output of one hidden layer, and this output can be fed back to the previous layer again to retain or the previous inputs and to achieve the right result. And following these feedback paths, we can achieve the right result and then we can get the output from the output layer. So that is the basic difference between our RNN and the earlier studied feed-forward neural network. After this, let us talk about some of the applications where we are using nowadays this recurrent neural network. The first one, for image captioning. What is image captioning? In this, if a particular photograph is shown to you, you can caption this particular photograph into some words. You can convert that pictorial data into some words. That is called captioning. Like if you have in a photograph some people sitting on the beach, so you can just write a caption, people sitting on beach. So this is that the photograph is described into some textual terms. So that is what is image captioning. So RNN, they are used to caption an image by analyzing the activities that are present there in our pictorial representation of data. Then for the purpose of time series prediction, any time series prediction like the prices of stocks in a particular month, these kind of applications where we want to predict certain things. For time series predictions, these kind of problems can be easily solved using the recurrent neural network. Then again, natural language processing, that is NLP. Basically, the text mining and the sentiment analysis, they can be carried out very easily using our recurrent neural network. They process the natural level language that we speak, and for that purpose of understanding or processing of natural language, we can make use of our recurrent neural network. Then, for the purpose of machine translation, that is, we are given an input in one language and we can translate that input into different languages as output. That is called machine translation. Machine translation means taking the input in one language and converting it into some other language. That machine translation can be done with the help of recurrent neural network. So these are the few basic applications where we can apply recurrent neural network. Other than this also, there are various fields in which these recurrent neural network can be used. There are, as everything has certain advantages, we do have certain disadvantages in our recurrent neural network. Some disadvantages, we can call them some issues, some drawbacks of using recurrent neural network. First is a vanishing gradient problem, and second is the exploding gradient problems. These are two issues which are just the opposite of each other, and our recurrent neural network, it definitely faces these two kind of issues. So first one is vanishing gradient problem. A recurrent neural network, it suffers from the problem of vanishing gradients. The gradients, they carry information that we use in recurrent neural network, and when the gradient becomes small, too small, the parameter updates, they become insignificant. So, this makes the learning of long data sequences difficult. That means when our gradient becomes too small, the parameter updates that we are updating, it will become insignificant. So, this will make the learning of long data sequences difficult. This is called vanishing gradient. That means gradient is becoming too small, it is vanishing. It will not affect the inputs further. So, that is one issue that we have in our recurrent neural networks. Second is the reverse of it, that is exploding gradient problem. While training a neural network, if the slope tends to grow exponentially, so instead of decaying, it is growing exponentially. This is called exploding gradient. This problem, it arises when large error gradients accumulate. So this will result in large updates to the neural network model weights during the training process that we are going through. So when we have large error gradients, many large error gradients accumulate. So this will furthermore result into large updates. So our training process, it will not work efficiently. This is called exploding gradient problem. So the two major issues of our recurrent neural network, the one is the vanishing gradient problem and the second one is just the reverse of it, that is the exploding gradient problem. So long training time, poor performance and bad accuracies, these are the major issues in these two gradient problems. Because of these two gradient problems, one of which is the vanishing gradient and the second is the exploding gradients, the major issues that occur is that we can have long training times, we can have poor performance and bad accuracies. So these are the few major issues that gradient problems may incur into our recurrent neural network.